All right, we're doing like the calculator portion of the number E.
Wait, what number is this?
4.2. All right, guys, the number E on your calculator, there is a button that says LN. Everybody see the LN button? On top of LN is e to the x. If you hit second LN, E will come up, and then it goes to an exponent. E is a programmed number into your calculator, just like pi. Pi is 3.1415, blah, 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 blah. All right, this is E. Good. This is E. If you don't have a calculator, you cannot evaluate anything that has to do with E, our natural logarithm, because it's an irrational number that you guys don't know and you can't work with by hand. So you have to have your calculator for this. We're going to do the calculator portion today, and then on Monday, we're going to do, like I said, the mechanics behind everything. But on your calculator, E is on the same button as ln. So if you are looking at this is an exponential function. How do you know it's an exponential function? Because it has a base, right? That base is a number. It's 2 point blah, 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 blah. And the exponent is a variable. That's what makes it an exponential function. This just happens to be a specific kind. It's called the natural exponential function. E and ln are inverses of each other, which we'll talk about in sections 4, 3, 4, 4, 4, 5, and we solve and stuff. But just understand what that means. An exponential function, we talked about yesterday. The natural exponential function has the same shape. If it's a growth or a decay, that sort of a thing, that's fine. But your parent function of e to the x looks just like our exponentials from yesterday. If I plugged in 0 right here, if I plugged in 0 for my e, what's that value going to be? What's e to the 0 power? 1, right? So it's going to cross it at 1 on the y-axis. Now, when we're evaluating, for those of you who have calculators that you have to work back, inside out or backwards, you have to hit the 3 and then hit the second ln button. But for those of us who have calculators that don't have to work backwards, when you evaluate, you hit second ln, that e comes up, and then you hit 3, and you get 20 points. It says 5 decimal places, so 0, 8, 5, 5, 4. Again, if you have a calculator, you have to work backwards. For letter B, you'd have to hit the exponent, then the e, then multiply by 2. But understand, guys, when you're doing this in your calculator, I'm going to hit 2, second ln, the e comes up. Then I have negative 0.53. Negative and the minus sign are two different things. Most of your calculators, if you put a minus sign instead of the negative, it'll tell you error. And it's because they're two different things. So when you evaluate this, you get 1.17721. If you're not getting that, let me know, and we'll look at it on your calculator. And then if you're evaluating the last one, E, so second E to the 4.8, and you get 121.51042. All right, so evaluating, that's just plugging in. You guys need a calculator for that. Here's an example of a word problem that you might be given that you might have to use. It says an infectious disease begins to spread in a small city. After T days, the number of people who have succumbed to the virus is modeled by. Okay, unfortunately, COVID is a really good example of an exponential function. It started off with 1 or 2 people and then went worldwide in a hurry. And this is an example of that. If you guys have, you're given an equation, and you're asked to find what happens over a certain amount of time, right? If I want to know initially how many people are affected, initially means at the beginning. So they tell you to use t equals 0. So in your calculators, this is just practice with your calculator. You have 10,000 divided by 5 plus 1, 2, 4, 5. Hit second ln. And then you have negative 0.97 times 0. Now, this is really good practice because some of you are going to get really weird numbers. You should get 8 when you do this. If you didn't, we did something good. Some of you are looking at me like, I did not get that. Then you did something wrong with parentheses. You might need to put this in parentheses, Or you did all of that in your calculator and you got 8, and you're like, what? How in the world did that happen? All right, well, think about this, guys. If you plug in 0 for t, this makes your whole exponent 0, right? Well, what's e to the 0 power? Not 0, it's 1. So when you plug in 0, what you're really getting here is 10,000 divided by 1250, right? And that's where you get 8 from. Now, you could do that by hand, absolutely, but the rest of them you can't because you have to use the value of e, and you guys don't know that in your head. You won't be able to work it out in your head. So let's work out this equation after 1 day, 2 days, and 5 days and see the difference. So here we're going to do where t equals 1. Here we're going to do where t equals 2. And here we're going to do where t equals 5. I'm going to show you the example of an exponential equation and how I said yesterday it gets big in a hurry. So in this case, we have 10,000 divided by 5 plus 1245 e, and that's raised to the negative point, is it 97? Yeah, negative 0.97 times 1. Some of your calculators will do order of operations, some of them won't. You have to put this in parentheses. Now, guys, you all have a calculator, and I don't mean this mean when I say this, but a calculator is only as smart as the user. If you don't plug it in correctly, you're not going to get the right answer out. So let's work on this. 10,000, and then I have 5 plus 1245, second ln, negative 0.97 times 1. And we got 20.966. How many people is that about? About 21, okay? So initially, 8 people got this disease. After 1 day, it was up to 21. So let's see what happens after 2 days. So you have 10,000 divided by 5 plus 1245 e to the negative 0.97 times 2. This is really good practice of entering stuff in your calculator. So 10,000, 5 plus 1245, second ln, negative 0.97 times 2. Yeah.
How would you do all this? You would do the negative
You're going to do, you would have to do separately. You would have to do negative 0.97 times 2. Then hit second and the ln button times 1245 plus 5.
183.91.
So you have 10,000 like this. Hold on. Then what was it? 1? What was it? 1?
183.9114.
Okay. So what is 10,000 divided by 183 point? Yep. You'd have to then divide that by 10,000, or 10,000 divided by that. But you get 54.37. How many is that? About 54.37 people. It's about 54, right? So initially, 8 people had the virus. After 1 day, it was 21. After 2, it was 54. Do you see how quickly exponential functions grow? And again, unfortunately, COVID is a good example of that. But here I have 10,000 divided by 5 plus 1245 e to the negative 0.97 times 5. Let's see what we get. So 10,000 5 plus 1245 second ln negative 0.97 times 5. 678.134. About how many? About 678. So initially 8 people had this disease. After 5 days, 678 did. When you have an exponential function, I know sometimes they look silly. I know sometimes it looks confusing. But you guys cannot do this without a calculator. You would just sit there and be like, I don't know. So you have to have a calculator. Please try to come to class tomorrow with one so you can ask me some questions. All right. Yesterday we talked about our interest formula. Remember it was this one? A equals P times 1 plus R over N to the NT. What did R stand for? The rate. All right. What was our N? What was P? Let's put it that way. Let's go principal, which you start with. What is T? the number times. So n. N is how the interest is compounded, whether it's weekly, monthly, daily, something like that. All right? There's another way that interest can be compounded. And it can be compounded what's called continuously. That means nonstop. If something is compounded continuously, use a different formula. You use this formula right here. And I always say, when I see something compounded continuously, I think of my friend Apert. Right? P is my principal, R is still the interest rate, and T is the number of years. In this case, guys, continuously doesn't give you an end value. Quarterly, weekly, monthly, that's your end value, how something is compounded. If it's continuously, it's just nonstop, it's never ending. It's always, 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 always happening. So that's why I use a different formula. You use the E button. So if I have a question like this, let's identify all the stuff that we have. What is 3 years? What is that telling me? That's the what? That's the T, that's the time. We're talking about 3 years that this money's sitting in an account. What is the initial amount? What's 1,000? That's my principal, right? What you start off with. It says $1,000 is invested. And what is the interest rate? 12%. But do I use 12% in my calculations? No. It's what? 0.12. And it says right here, it's compounded continuously. That does not give me an end value. That doesn't say weekly, monthly, yearly. Continuously. Who do we think of when we think of continuously? My friend who? Apert. My friend Apert. And I'm going to put this in just like this. I have $1,000. And then I have E. And it's going to be raised to the 0.12 times 3. And let's see what we get. 1,000. Second ln. If I can use my calculator correctly. And then I have 0.12 times 3. What'd you guys get? 1,400. Whoops. 33?
Yeah.
0.33. Okay. Now, guys, what we talked about this yesterday. What did I start off with? $1,000. So after 3 years, I'm at 1,433. Should you start off with $1,000 and after 3 years be in the billions? No, then you did something wrong. Go ahead, practice this. Do this equation and use 12 instead of 0.12. See what happens. So I have 1,000, second E, and then 12 times 3. What do you guys get when you do that in your calculator? This is what I got. Okay? Some of your calculators don't go up that high, and it'll say error. I guarantee you there will be people on your quiz that I tell you the initial amount is $1,000, and you tell me after 3 years you now have this amount of money. And there were people that will not even think twice about that. Guys, that right there doesn't even make walking around sense. So when I'm telling you to listen to yourself for a second, trust yourself a little bit. If you do something in your calculator and you get a wacko answer like that, that's probably not the answer. Can you come up to me and be like, I think I did something wrong? I'll say, yeah. If you say, what did I do wrong? I'll be like, that's not for me to figure out, right? It's important that but you have to know and understand when you can check yourself and say, like, hey, I made a mistake. Like if you take your calculator right now, guys, what is -2 squared? Tell me, what's -2 times -2? 4, okay? Everyone in here knows that. If you put in your calculator -2 squared, just like that, don't put anything around it. If you hit -2 squared and hit enter, what does your calculator say? It says -4. Is that true? The way that it's written, that is true. But you guys are going to tell me, I put in -2 squared, my calculator's broken. No, it's not. The calculator is only as smart as what? The user. This top problem here says, hey, calculator, take -2 and times it by itself. Square it, because it's in parentheses. This says, hey, calculator, square 2, and then multiply it by what? -1. All right, so a calculator is great because it makes things a little quicker. But if you don't know how to input things, if you don't know how to input this, you're not going to get the right answer. So it's important that you guys know and understand. I know some of you are just like, oh, she doesn't stop talking. Come quiz time, when you walk up to me and say, I don't have a calculator, I'm going to say, sorry, I'm not going to run around trying to find you one. You guys have to have a calculator that you know how to use. Everybody understand? All right.